And I'm certainly glad to have an opportunity to share with you guys not only our view as it relates to TinyML, but also have the opportunity to introduce a number of different experts in this particular area that I'm certainly sure that all of you guys will get some value during the course of not only today's event, but over the next couple of days as well. So with that said, we can get started. One of the things that I've learned when it comes to TinyML is TinyML, of course, it covers a number of different, I would say, skill sets. We have a number of different experts or individuals who may have an expertise, let's say, in embedded engineering. We have some experts and participants who may be very well experienced in machine learning. We oftentimes have some individuals who are just new to the TinyML field overall. And for me, that's one of the beauties about TinyML is that it covers experiences and it covers expertise from a wide range of fields, which actually for me, and certainly for us here at Neuton, it certainly creates an opportunity where we can not only participate, but we can help provide value in a number of different areas. So I like to oftentimes start off with that because as I begin to have an opportunity to speak with a number of individuals, it's often at times important to kind of level set or kind of come to a common understanding as does what does TinyML mean for everyone. So one of the things that I like to do is kind of align on what our view is as it relates to TinyML. And I'm sure our participants, not only today, but also over the next couple of days, will also share with you where they're focused at in this particular area. And when you begin to look at TinyML or edge computing, one of the key areas is how do we begin that process of really connecting the physical world with what we like to call the digital world. And in doing so, what we like to do is we want to accomplish being able to bring some significant intelligence into the physical world and make that particular connection. And that's one of the areas that we focus on here at Neuton, is we really enabling both of those two worlds to be able to connect and ultimately bring value, whether it's to yourself, whether you're working in research, whether you're on the business side. And I believe that we have a number of different experts throughout our event that will be able to share that experience. But where we really find where we bring a tremendous amount of value is connecting those two areas, whether you're working on the embedded side, whether you're building physical devices, whether you're working on the machine learning side. This is an area where we believe from a Neuton perspective, we really kind of connect the two dots, connect those two worlds, and ultimately enable you to accomplish your tasks and objectives as you move forward throughout your particular journey. Now, one of the areas that we like to start, where we find that it's oftentimes an area I like to say of opportunity. When I look at, let's say, the TinyML community, we tend to find that at the moment, there's probably more resources or experts, let's say, on the embedded side, and on the hardware side. And now they're faced with that challenge of being able to bring intelligence to that physical hardware, whether it's a sensor, whether it's an IoT device, it really doesn't matter. Now, in doing so, there's a couple of different challenges that we're oftentimes faced with. You know, does an organization have that data scientists available so that they can enable their devices with the necessary intelligence to accomplish their particular projects and goals? And in doing so, if you are familiar with machine learning, or even if you're not familiar with machine learning, historically, it's been an extremely manual approach. It's been an extremely iterative approach. And needless to say, of course, you oftentimes need to have an extremely high level of expertise available in your organization to be able to produce the necessary models to integrate those models into your devices. And then, of course, if you're fortunate enough to have those resources available within your organization, and you take that first initial step of being able to create a model that you find that operates at your expectations, then you need to take that next leap, that next step, and say, now, how can I now integrate this model into the hardware that I've decided to work with? And we found that traditional models are extremely large, and they don't oftentimes fit the requirements from a physical perspective to be able to integrate into those devices. So we're faced with performing a number of different tasks from a compression perspective. And there are tools that are out there, such as TensorFlow Lite, et cetera, that you can take advantage of that can help you accomplish that goal. But one of the things that we also learned is that when it comes to TinyML, the size of your models, the amount of power that you're consuming, that is ultimately your currency, because you want to be able to make sure that you have a model that's not only small, but is extremely efficient, so that you're not consuming all of that valuable real estate that's on your hardware device. And one of the things that I like to show here is that not only is it's an extremely manual process, but it also oftentimes can take an extremely long amount of time. So if you're a business user that is out there and you're worried about the time to market, that's one of the areas that you have historically have to be concerned with. And then, of course, once you produce that model, then you need to begin to think about, hey, does the model perform as expected? Can I trust this model? And oh, by the way, when will I know if that model may begin to decay along the way, so that you can maybe potentially retrain that model? And we kind of like to look at this as the legacy approach as to how oftentimes TinyML, or the process of being able to produce models, have historically been followed. And Neuton, we're taking what I like to say, we're really kind of flipping the paradigm on its head, and we're really taking a significantly different approach to enabling our partners, our customers, to be able to complete these tasks, and oftentimes, 70% of the time than what it would take you normally by doing it manually. So what's our approach? Our approach kind of follows really three very critical steps. Number one is we want to be able to enable all of our partners, all of our customers, to be able to produce a model efficiently. And this is where we begin to talk about accelerating your go-to-market. So when you begin to take a look at Neuton, Neuton is a zero-code AutoML solution that enables you to produce models efficiently without compromising accuracy in one iteration. You may recall, and even for those individuals who have experienced yourselves building models, it's an extremely iterative process. You go through, you build a model, and you look to try to validate if whether that model meets your expectations from a business perspective, as well as from a technical perspective. And this is one of the areas that, quite honestly, we truly excel at. So all of the models that we build, we start out by building all of our models neuron by neuron. We don't start out with an existing structure that ultimately ends up with a lot of waste, where you have to go through compression, pruning, distillation, et cetera. We've eliminated all of that. So as we build all of our models neuron by neuron, we perform cross-validation along the way, so that by the time you've reached your model, your ideal level of accuracy, you do not need to perform any compression along the way. So this is where we say we enable our customers to build fast, because you don't have to go through that iterative process, number one. Number two, you only have to go through one iteration. And then lastly, when we begin to talk about never compromising, this is the area when we begin to talk about our explainability office. Our explainability office gives all of our customers, all of our partners, the transparency that they need to see into all of our models. And in doing so, we also provide a lifecycle management tool for all of our customers, so that they can proactively identify if there's experiencing any model decay, and they may need to train their specific model. So this is the approach, really kind of a three-step approach, and really highlighting the three fundamental areas that we have found that our customers find extremely valuable. Now, what's some of the results? What's some of the value that you can get out of our platform once you have had the opportunity to take advantage of our platform? We have found that consistently, all of our models oftentimes are up to 1,000 times smaller than what you may find from other competitors or other frameworks that are out there. And in turn, being able to produce a model that is extremely compact. And as I mentioned, we're not compromising accuracy along the way. You also find that you're going to have a faster inference time when you come to running your predictions, et cetera. And of course, with these compact models, they're going to run much more efficient on your devices, on your microcontrollers, or whatever you're using as it relates to, to your particular project. So that's another area that we are extremely proud of. Now, when we begin to talk about TinyML, and I've had the opportunity to speak at a number of different TinyML summits, there's certainly aspirations and goals that we will find millions, if not billions of devices in our future that have intelligence. And one of the areas when we began to have a number of different discussions with various individuals throughout the industry, we begin to look at what are some of the key challenges that are out there that is preventing the acceleration and adoption from a TinyML perspective. Certainly, the ability to be able to build models efficiently, or the number of different data scientists that are out in our ecosystem today, is extremely limited. Number two is being able to make sure that you have a model that is not only accurate enough in order to meet your business expectations, but it also can integrate into your respective devices that you're taking advantage of and leveraging into your particular project or your particular implementation as well. And then, of course, lastly, from a business perspective, we want to be able to make sure that we understand how our models are executing, why they're making the predictions that they are making, and then, of course, as I've mentioned, being able to determine, hey, when do you may need to take the next step of retraining. So we also address this component by providing a complete lifecycle management tool for anyone that we may have the opportunity to work with. So hopefully that kind of gives you guys a really good overview and foundation as to what we're doing here from a Neuton perspective. And certainly one of the things that we want to do, because of course, being able to enable the community is not only key to our success, but it's key to everyone's success. And that's one of the key reasons why we've decided to host this event and bring forward to all of you guys a number of different experts over the next couple of days that certainly all of you guys will, I believe, get an extreme amount of value out of. Now, one of the areas that I've mentioned is that TinyML covers a number of different areas. Of course, it not only covers the hardware side, but also it covers machine learning, et cetera. And also one of the things that I wanted to share with you guys is that it covers a number of different areas as it relates to experience. So when you begin to look at today's agenda, we'll start off today. Today's agenda will be kicked off by Danilo Powell, where he'll be covering handcrafted ML design methodology and the challenges that it poses. And I'll introduce formally Danilo in just a moment. From there, we'll have Sumit Kumar, who will be talking about one of the use cases that has been implemented. He's been able to implement from an agricultural perspective. And then also for today, you'll be joined by one of my colleagues who will give an overview as to how you can be enabled, as I mentioned before, to be able to produce these models in 3 very simple steps along the way. Going into day 2 will be the beginning of where we will offer a number of different master classes that we will make available to all of you guys. So number 1, we'll share experiences on the hardware side, also on the implementation side. And then from there, we'll go into a number of different days where you'll be able to take advantage of a number of different areas. So starting first with Suram Anugna, we will have a master class on the TinyML creation on TensorFlow. Specifically, we'll be talking about classification. During this day, also, there will be a competition that we will make available so that you guys can participate and receive some goodies, if I'm not mistaken. Day 3 will be a masterclass by Dr. Prumit on regression and front-end ML solution. We'll be talking about ML model-based APIs and a front end with Streamlit. And then wrapping up with day 4, there will be a masterclass on the end-to-end process of creating and embedding tiny ML models on a microcontroller leveraging Neuton. And there will also be a competition award that day. So to kind of wrap up the week's events. Now, one of the areas that I kind of like to mention is that our idea, our focus with today's event, or just this event in general, is we kind of want to take you through the entire life cycle. So when I talk about the entire life cycle, it is really from beginning your journey as it relates to maybe what you're deciding to do, your decision making from a hardware perspective. And we're going to end today with showing you an actual implementation of being able to develop a model and embed that model by leveraging Neuton along the way. So that's